Okay, so today we are going to work on how to find the area of different figures, mainly squares, rectangles, and triangles. And what you have to focus on is the length and the width. Now, we talked about on Friday, we talked about the perimeter, which is the outside measure. But the area is your inside measure. And area is usually done in squares. So you would have square meters, square feet, square inches because it's inside. And let me give you a visual representation of what that would look like. That's very different from what we did on Friday. Area is the amount of space that's inside of a shape. So I have this rectangle, and notice I'm building small little rectangles on the inside of this particular figure. This is an illustration of what the area is. It's the inside measure, not the outside measure. So if I'm talking about covering a floor or covering the surface of something, I'm talking about the area inside. Don't forget that area is measured in square units because you're going to be doing a multiplication problem here. So if I had 1 centimeter by 1 centimeter in a square, this would be 1 times 1, which is 1 centimeter squared. So you're always going to either say the unit squared or just say squared centimeters. There's two ways to write it. Now I want you to look at these 4 shapes and then tell me, here's shape A, here's shape B, here's shape C, and here's shape D. Tell me by just looking at these what your educated guess would be for what is the smallest to what is the largest. So what would be the smallest area there that you see? What's the smallest? D? Okay. Or B? D? Okay, and then what's after D? Next smallest. A? And then what? C? And you're saying B is the biggest? B and then what? B and then C. Okay. Now, a lot of times we can't just eyeball it, especially if you have a room, one of these shapes. You're going to want to actually measure it because when you go down to buy the carpeting or the flooring or whatever you're going to be buying, you want to be as accurate as possible and have a little leeway for a little extra so that you can trim. So let's actually put some squares in here and see how big these are. So I put the same size squares in each of these areas. And now we're going to actually calculate and see which is bigger and which is smaller. So this first one is 1, 2, 3, 4, 5, 6 across and 6 down. That's 36 square centimeters or units, whatever this is. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 3 is also 36. So even though B may look smaller than A, they are the same size. Then for C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 4. Well, 9 times 4 is also 36. And the last one is 2. We have 2 rows times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 times 2 is also 36. So all